Hi everyone. In this part we are going to look at an application of implicit differentiation. We will show how implicit differentiation and the chain rule can be used to calculate the rate of change of one variable in terms of the rate of change of another variable, which may be more easily measured. Related rates problems can be identified by their request for finding how quickly some quantity is changing when you are given how quickly another variable is changing. There exist a few classic types of related rates problems which you should familiarize. But before this, let me give a strategy to solve related rates problems. First, it's better to sketch a diagram or figure if it's helpful, and second, identify all relevant variables, including those whose rates are given and those whose rates are to be found, and then express all given rates and rates to be found as derivatives. Later, find an equation connecting the variables in the previous step. And finally, implicitly differentiate the equation. So, the most important step is to write down an equation for the given problem. There exist a few classic types of related rates problems which you should familiarize. The first one is the falling ladder. The first one is the falling ladder problem. Falling ladder problem. The second one is leaky container. The third one is lamppost and the shadow. And the fourth one is the change in angle. Okay. And do not forget that when we talk about how a quantity changes, we talk about the derivative of that quantity with respect to time. For instance, if we say Michael is growing at the rate of 8 centimeters per year, it means the h over dt is 8 centimeters per year. Okay? Or if we say the volume of a cone is decreasing by 6 centimeter cube per second, it means dv over dt, since the volume changes by time, dv over dt is equal to minus 6 centimeter cube, since the volume is decreasing. We have minus in this case. So we mathematically can express every physical event or situation. So let's look at the first easy question. X is given as y cubed minus y prime is 5. Then what is the value of x prime with respect to t when y is equal to t? And as you see, one quantity is given and the change in the other quantity is requested to find. Now in this question, the equation of the problem is given. So and do not forget that each variable is a function. Actually they are not variable. Each notation is a function of t. So x and y change with respect to time. This is why x is actually x of t and y is equal to y of t. So we will take derivative with respect to t. Y is equal to y of t in this equation. So derivative of x is dx over dt times derivative of y cube is 3y squared times y prime, and final derivative of y is y prime. So the aim is to find dx over dt, and dy over dt is given. If you make dx over dt alone, we will easily find dx over dt. And the second question is also given. We don't have a story for the problem. The equality is given. The equality is r plus s square plus v cube is equal to 12. dr over dt is given. ds over dt is given. And the question is, what is the value of dv over dt when r, s, and v are given as in this problem? So again, do not forget that r, s, and v are all the functions of t. So we will differentiate each term with respect to the variable t, and finally we will easily find dv over dt using the information given in